Okay, we have a short one regarding titration here. So we have 25 milliliters of an unknown monoprotic acid. So we know it's monoprotic, and we want to determine the concentration of the acid by titration. Very straightforward. The student uses a standardized solution of 0.110 molar sodium hydroxide, a burette, a flask, an indicator, and whatever we need. We're doing a titration. Very standard. So this is the information they're giving us. So it's almost as though we're actually physically performing the titration. It's saying the images below show the burette before the titration begins, and then at the end point, right here, what should the student record as the volume of NaOH delivered to the flask? So here we have some base. We're doing the titration. The indicator tells us the equivalence point has been reached, and that's this point right here, so we stop. And then this volume of base added, that's our initial datum from which we make all of our calculations. So what does this look like right here? We've got 5.12345.6.7. It's in between 5.6 and 5.7. So there's probably a little leeway, but why not just go right in the middle and say that this is 5.65 milliliters, right? It's right in between 5.6 and 5.7. Then over here, 37.123. That looks to be right on the 3. So let's call this 37.0, 0.00 milliliter. Or sorry, what did I say? 37.30 milliliters, right? 37.123. So we have to make good estimations, and we have to go to the hundredths place, right? Remember, whenever we're making a measurement and we have some measuring apparatus, whatever the gradations are, right, whatever the degree of precision is that is given to us, we estimate one additional decimal place or one additional place value, right? So if we have tenths of a mil, we have to estimate hundredths. So 5.65, 37.30. So how much of the base was delivered to the flask? We can say 37.30 milliliters minus 5.65 milliliters equals 31.65. Let's put that down here. 31.65 milliliters. That is the amount of base that was delivered, and that is the data we're going to use here. So based on the given information and your answer in part A, determine the value of the concentration of the acid that should be recorded in the lab report. So this is the point of the titration. We added some volume of base of known concentration. We're going to use it to get the concentration of the unknown monoprotic acid. So what are we going to do here? Let's take our concentration. We know that we have 0.110 moles of base per liter, and let's multiply that by the volume the volume in liters. So we have to convert this to liters, 0.03165 liters. Okay, so if we were to do that, that would give us the moles of base. We're using the volume and the concentration to go to moles. Now, sodium hydroxide, and that's interacting with a monoprotic acid, so those will react 1-to-1. Every molecule of acid will react with one hydroxide ion to do one neutralization. So this will be 1-to-1. We can just put 1 mole acid over 1 mole base just to be thorough. Just to make sure everything cancels out the way we want it, right? Base, get rid of base, get rid of base. But we just, even if we don't want to write that, we know that it's 1-to-1, right? However many moles of base are involved in the neutralization, that's the same as the moles of acid. And once we have moles of acid, we want concentration. We want moles per liter. So let's take our moles of acid and divide by the liters of the solution. So 1 over 0.0250 liters, right? This is a 25 milliliter sample. That's 0.0250 liters. So we just plug all that in and we get 0.139 molar. That is the concentration unknown monoprotic acid. So we took our concentration of base, multiplied by the volume to get the moles of base, acknowledged that because the acid is monoprotic, when it's precisely neutralized, we've however many moles of base we added, that's how many moles of acid that were in there, and then divide by the initial volume of the acid to get the concentration of the acid. So that's part B. Then C, in a second trial, the student accidentally added more NaOH to the flask than was needed to reach the endpoint, and then recorded the final volume. Would this error increase, decrease, or have no effect on the calculated acid concentration for the second trial? So, remember, in order to achieve the neutralization, precisely we're adding exactly the same number of moles of base as there are moles of acid. So if we accidentally add too much base, that is going to give us an erroneous calculation for the moles of acid. If we put more base than we need to do the neutralization, it will make us think that we have more moles of acid than we do, right? If we are thinking if we only need to add 1 mole of base because there's only 1 mole of acid, if we accidentally add 2 moles of base, it'll be as though there were 2 moles of acid. And if there are more, if the numbers are telling us there's more moles of acid than there actually are, the concentration will get a concentration that's too high, right? Because the initial volume isn't changing. The initial volume was 25 milliliters, right? And so if we have too great a number for the moles, this will increase the calculated acid concentration. So that's pretty straightforward. You accidentally added too much base, then it would appear to be that there's more acid than there actually is, which means a greater concentration. So this was a pretty straightforward one regarding titration.